Hi, welcome to another mini lecture. Today's topic is using the Pythagorean theorem to find a sine, cosine or tangent ratio in a right triangle. So let me just quickly remind you that if you have a right triangle, say with sides A, B, C, we of course have a squared plus b squared is equal to c squared. You can always find one of these sides in terms of the other two. So these are some of the forms that you might have. So a, you can write it as square root of c squared minus b squared. Also, let's just remind ourselves, we call this angle, say angle B, then sine of B is the ratio of the opposite to hypotenuse. Cosine of B is a ratio adjacent to hypotenuse, and of course tangent of B is a ratio of opposite to adjacent. So we have these two sets to help us answer the questions here, and the problems asking you to give exact values. So more than likely in this section you are going to find lots of radicals. Previous lecture we had those magical situations where all three sides were whole numbers, but that is rather rare, and more common situation is that you have radicals in your solutions. So in this case we want to find cosine of theta. Let me just refer to these as A and B, and this is C. So remember that cosine of theta, ratio of adjacent to hypotenuse. So adjacent of it is A, hypotenuse is C, and we have A and B but we don't have C. Well, of course C squared is equal to A squared plus B squared. So C is equal to square root of A is 3 and B is 5. So C is equal to 9 and 24, and that seems to be 34. So cosine is going to be ratio A is 3, and C is square root of 34. It's not required that you do any kind of rationalization or anything. You can just leave it like that, just so that we get most benefit out of these problems and practice extra. So what is sine of theta? Sine of theta will be opposite 5 over radical 34. What if they had asked us for tangent? Well, tangent didn't require calculation of C, would have been just 5 over 3, and that one would be a rational number. Same problem in all of these. So here we have cosine of theta. Again, let's call these things A, B and C. So here we have cosine, which will be, I have to find the ratio of, so cosine of theta ratio is adjacent to C, and I need the A. So what is A? A is square root of C squared minus B squared. So when you want to calculate one of the legs, it's hypotenuse squared minus the other leg squared in a square root. If you want to calculate the hypotenuse, sum of the square of the other two. So in this case, what do we have? We have 25 squared minus 24 squared. Of course, you use your calculator to find out what this thing is. This becomes 25 minus 24, which is 1. 25 plus 24 is 49. Product of them is 49. Square root of that is 7. So we got one of those magical situations. This became 7. So A over C in this problem becomes 7 over 25, and if we were asked for sine, it would have been 24 over 25, and if you wanted tangent, it would have been 24 over 7. Of these, this was available to us without any calculation, but the other two we needed to go ahead and calculate a to be 7 and then we'll be done. Excuse me. So here another example. Let's call again a, b, and c. We want tangent of theta, which is the ratio of b over a. I need the a. So what is a? A will be 17 squared minus 15 squared. So what is that? So let me write the steps of it. So if you want to see 289, so I have 17 squared and then minus 15 squared, so that would be 225, and then again we get lucky and here is a 64. Square root of that is an 8, so b over a is 15 over 8. And of course cosine of theta would be, so this turned out to be 8, 8 over 17, and what else? Sine of theta would be 15 over 17, and again this one did not require that calculation of the third side. It was available to us at the very beginning. So these are possibilities. In the first example we have 3, 5, and then c turned out to be square root, and so if it is so, then you have to use this symbol, otherwise you just use this one. So remember, you are supposed to give exact value and no calculator in this, so you have to do these things by hand probably if it is needed. Okay, this was another short lecture. Until next time, good luck and God bless.